Hi, this is the second videos on the antiderivative. So basically we're still discussing chapter 4 and the section 9. We call that the antiderivatives. So let me just go back to the title. We already did this in video 1, so we're going to continue with the second video on the antiderivatives. So we'll proceed with this new example that is we are given the second derivative of the function f of x, which is 1 minus 6x, and they give us this condition f prime of 0 equals 3, and they give us another condition f of 0 equals 8, and the question is to find the function f. So these are what they give us. Okay, so we will use these two conditions as we try to find the function f of x. So we start with the second derivative of f of x, which is 1 minus 6x. So as you know, the process is that to get to the function f, you'll have to go to f prime first. Okay, so we're going to go from f double prime to f prime and then to f. So to go from f double prime to f prime, you need to take the antiderivative of f double prime. And then to go from f prime to f, you'll have to take the antiderivative of f prime. So let's start. We take the antiderivative of f double prime on the left side, we get f prime of x. On the right side, we take the antiderivative of 1, which gives us x, minus, we take the antiderivative of 6x, is basically 6x squared divided by 2. So, and then plus c. So then we simplify 2 to get f prime of x equals to x minus 3x squared plus c. So now that we reach here, we go back to the original problem. There is a condition imposed on the first derivative. It says when you take when you have the first derivative function, if you plug in 0 for that function, you're going to get a 3. So since we get the first derivative function, which is f prime of x equals x minus 3x squared plus c, we're going to use that condition f prime of 0 equals 3 into the f prime of x. So what does it mean? It means when x is 0, f prime of x equals 3. So we plug in 0 for x into the first derivative. You get f prime of 0 equals 0 minus 3 times 0 squared plus c. And the left f prime of 0 is a 3. So the left side here is 3. On the right side, when you evaluate everything, you get the 0 minus 0 plus c, which give us basically c equals 3. So we go back to the equation of f prime of x, which is x minus 3x squared plus c. We replace the c by 3 that we just got. So that's what that condition was there. It was here to solve for c, to find the values of c, which is 3. So now we have the f prime of x, which is x minus 3 squared plus 3. So we're still going to f by taking the derivative of the antiderivative of f prime of x, which gives us f of x on the left side, and then we take the antiderivative on the right side, which is x squared over 2 minus 3x cubed over 3 plus 3x and then plus d. After simplification of 3, we get f prime of f of x equals x squared over 2 minus x cubed plus 3x plus d. And then we use the second condition that they give us, f of 0 equals 8. So we go to this function f of x, we plug in x equals 0, wherever x is, and then plus d. And then we know, based on this condition, this side will be 8. So we get 8 equals d basically. And then you go back to this function, you replace d by 8, and then you get the function that you're looking for. So the function that we're looking for is f of x equals x squared over 2 minus x cubed plus 3x plus 8. Another example is this one. We again here they give us two conditions. Okay, so they give us first f double prime of theta, which is sin theta plus cosine theta, and they give us f of 0 is 3, and then f prime of 0 is 4. So again we have to go from f double prime to f prime and then to f. So by taking the antiderivative 2 times. So when we take the antiderivative of f double prime, it gives us f prime of theta. We know the antiderivative of sine theta is negative cosine theta. Plus, we know the antiderivative of cosine theta is sine theta, and then plus c. And then we use this condition f prime of 0 because we have f prime of theta. Basically, when theta is 0, f prime of 0 is 4. So we go to this equation, we plug in 0 wherever theta is. Okay, and then we know f prime of 0 is 4. So we put 4 equals cosine of 0 is 1, so you have negative 1. Sine of 0 is 0, so you get plus 0 and then plus c. So on this side you get 4 equals negative 1 plus c. When you add 1 to both sides, you get a c equals 5. So you go to this equation, you replace a c by 5. So you get plus 5. And then from this equation, you take again the antiderivative of f prime of theta, which gives us f of theta. And then we know the antiderivative of cosine is sine. So you're going to have negative sine theta here. The antiderivative of sine is negative cosine. So you get negative cosine theta. The antiderivative of 5 is 5 theta. And then plus d, the new constant. And then we use the second condition they give us on f, is that f at 0 equals 3. So we go to the f function, we plug in 0 for theta, wherever theta is. So you put 0 here, here, and there. And then you get, and then on the left side, f of 0 is a 3. So you write the 3 equals, sine of 0 is 0, cosine of 0 is 1, so you get negative 1 here. 5 times 0 is 0, and then plus d. So add 1 to both sides, you get 4 equals d. And then you go back to this equation, replace d by 4, so you get the f of theta that you're looking for. Another example here is applications. So what happened here is for the application we have, let me just introduce this first. For the applications, we know that if you are given a position function, you take the derivative of the position function, you get the velocity function. If you take the derivative of the velocity function, you get the acceleration function. Okay, so we're going to do it backwards now. So if you are given the acceleration function, you take its antiderivative, it's going to give you the velocity function. If you take the antiderivative of the velocity function, you get back the position function. So these are the steps that summarized here. If you are given the second derivative of the function s of t, when you take its antiderivative, you get the first derivative. When you take the antiderivative of s prime of t, you get s of t. So what is s double prime? S double prime of t is basically the acceleration. So what does it tell you? It tells you when you take the antiderivative of the acceleration, you're going to get the velocity function, which is s prime of t. And then when you take the antiderivative of the velocity function, you get the position function, which is s of t. So that's what we're doing here. Now let's go back to the application problem. So for this problem, they give us the acceleration function, which is 2t minus 7. They said that v, the velocity at time t equals 0 is at 3. And we call this the initial velocity. And then they give us the initial position, s of 0 is 9. Okay. So so they want us to find the position function s of t. So let's do that here. So we are given, so what is the acceleration function is the same as s double prime of t. Okay, so we want to go from s double prime of t to s prime of t by taking the antiderivative. So when you take the antiderivative of s double prime of t, you're going to get s prime of t, and then you take the antiderivative of 2t, you get a 2t squared over 2, minus, you take the derivative, the antiderivative of a constant 7, it's just the constant 7 times t, and then you put plus c. And then you simplify 2, you get a t squared minus 7t plus c. So s prime of t is the same as a v of t. So these are the same thing. So then they give us the initial velocity. They said the velocity at time t equals 0 is at 3. So we use this function, the v of t, to plug in 0 for t. So wherever t is, you put a 0, you get v of 0 equals 0 squared minus 7 times 0 plus c. But v of 0 is given as equals to 3. So you get a c then equals 3. So you go back to this function, you plug in 3 for c. Okay, so you get your new velocity function. But we know the velocity v of t is the same as s prime of t. If we replace v of t by s prime of t, then it shows that if we're going to take, to get s of t, we'll have to take the antiderivative of s prime of t. The antiderivative of s prime of t is s of t. So you get s of t equals to antiderivative of t squared is t cubed over 3 minus 7 times the antiderivative of t is a t squared over 2 plus 3 times t and then plus d. So, then we use the initial position, which is s of 0 equals to 9. So we're going to take this function, we're going to evaluate it at a t equals 0. And then on the left side, s of 0 then is 9. So we replace it by 9. But because we have zeros, plus d, which is just a d, so d equals 9. And then you go back to this function, you replace d by 9, and then you get your position function. So for this problem, the positions function s of t equals to t cubed over 3 minus 7/2 times t squared plus 3t and then plus 9. Thank you.